In this video, we're going to talk about two closely related things: margin of error and confidence intervals. Now, earlier we learned about a simple formula for margin of error that just said the margin of error is going to be 1 over the square root of the sample size. Now, this is somewhat useful, but it's limited. When we would use this kind of margin of error, and let's say we found out that, okay, we did some survey, turned out that 40% of the people surveyed prefer cats over dogs. 40% prefer cats. But the way that we conducted that survey, it turned out we had a margin of error of plus or minus 2%. That means if I wanted to know what percent of the entire population prefers cats, well, it might be a little bit higher or lower than what my survey results said. And that's where margin of error comes in, because then I would add or subtract that 2%, and then that gives me an interval. So here's where the interval comes in. The interval would be, if I subtract the 2, then that's 38%. If I add the 2, that's 42%. So give or take 2%, the 2% is the margin of error. And we could say that it's likely that the actual percentage of the population that prefers cats is between 38% and 42%. But listen how vague that sounded. I just said it's likely. Likely. What does that mean? How likely? I thought this was a math class. Why are you being so randomly vague? What can I even do with that information? I need more specifics. Oh, you say you need more specifics? Well, in that case, I've got a formula for you. So instead of using the simple margin of error that I just showed you, you can use a more advanced margin of error where we can talk about specific levels of confidence. And this margin of error formula involves a z-score, and it involves the standard deviation, which is what this is. And you still got the square root of the sample size in the denominator, just like in the simple version of margin of error. So using this formula, depending on what z-score we choose, we can have any level of confidence we want. So if we want a 90% confidence level, then we'll use a certain z-score for that, and I'll show you a chart in a moment. If I want a 95% confidence level, then I'll use a different z-score. And when I say confidence level, that means if we use this formula, depending on the z-score, we can be 90% sure that the true percent of the population who prefers cats is within the interval. You can be 90% sure or 95% sure or whatever. So we can be more specific than just saying it's likely that it's in the true percent is in this interval. We can say how sure we can be. So let's look at an actual problem. Now this is that chart I was telling you about that tells you which z-score to use. So if we want to be 90% confident, we'll use this z-score. If we want to be 98% confident, we'll use this score. So you might ask yourself, well, why don't we just go for the maximum confidence we can? Well, the higher the level of confidence, the wider your range is going to be. So it'll be less and less useful if I have to say, 40% of the people prefer cats, but the margin of error is 10%. So that means it could be anywhere between 30% and 50%. Well, yeah, maybe I can be 99% sure, but that's such a wide interval that it's not as helpful. So it's a compromise. Anyway, I'm talking too much. I just need to do the problem, don't I? So you want to find the average daily cell phone use for teenagers. You obtain the cell phone usage of a random sample of 400 teenagers in Fulton County. The sample mean is 240 minutes daily with a standard deviation of 40 minutes. Given a 90% confidence, find margin of error and the confidence interval. So these are not two completely separate problems. They say given a 90% confidence, colon. So as soon as you see that we're talking about confidence, that tells you that we should be using this version of the formula, not just the simple margin of error formula that looks like this. All right, this is not the formula that we're going to be using because they mention confidence levels. Okay, so let's go ahead and calculate that margin of error using the formula that I just showed you. So the margin of error is going to equal. Now I said z-score goes first. And here are the z-scores. So if I want 90% confidence, I'm going to use this z-score, 1.645. Okay, and then in the top here I'm supposed to have standard deviation. So let's see, it said standard deviation of 40. So 40 goes there. Now down here is supposed to be the square root of the sample size. So how many teenagers were surveyed or whatever. Random sample of 400 teenagers. So this should be 400. So if you put all this in your calculator, then that's going to give you the margin of error. You know, the margin of error that will lead to, in a moment, a 90% confidence interval. All right, so I'm getting 3.29. All right, so the margin of error is 3.29 minutes, or some people like to put plus or minus 3.29 minutes, give or take 3.29. Now, to find the confidence interval, we need to look back and see what did the survey say, or they didn't really say it in terms of a survey. They just kept saying sample. So what did the sample say? Or in other words, what does the sample mean? The sample average. Because we're going to take that sample mean and then we will add and subtract the margin of error. All right, take what the sample said and then do your margin of error. So that was a big hint. So looking through for the sample mean is 240 minutes. So the 400 teenagers that they surveyed, on average they spent 240 minutes. So let's start with that. Now if we want to know about the entire population, okay, estimating the entire population mean, we need to go a little bit higher or a little bit lower. Always subtract first because you want to go from least to greatest. So this is the confidence interval requested. This is the interval. Alright, so we can be 90% sure that the actual average number of minutes used by the population is somewhere between these two numbers.